Good afternoon, grade 7s. This is Mr. Ntuli. I'm here again, guys. I'm with you once again. I will be doing geometry of 2D shapes with you guys, but focus here. Our focus is based on similar and congruent figures. So it is different. We have already covered the first two. Now we are covering on similar and congruent figures. Hope, guys, we enjoy again on this one. Right, let us get to it. My lesson outline is as follows, guys. We always need to connect what we have done before with what we are going to do so that we know where we're coming from and where we are going. It is very important to know where you're coming from so that you can know where you are going. And then we need to know what resources, what things that we must have so that we can be able to complete this part successfully. We also have got to familiarize ourselves with the vocabulary and the meaning that is used. And then we're going to touch on the examples. And then we're going to do exercises together. Right. Now let's get to what we have already covered before with you guys. What was learned in grade 6? We learned about similarities and differences between rectangles and parallelograms in grade 6, guys. The similarities, meaning things that are looking more the same. And the differences, what could one differ from the other? Now, the resource that we're going to need, guys, first is a mathematical drawing instrument, as we are busy with geometry of 2D shapes. So the mathematical drawing instrument is going to be very important. Pen, 30 centimeter ruler, pencil, eraser, etc. Those are part and parcel of our stationery that we normally need to have before we can embark on any task. What more can I add there, guys, is this. Please have your book, have your vocab book. Some of us, we call it our word bank book. Some of us, we call it our dictionary book. Some of us, we call it a vocabulary book. Have that book handy with you guys, because there will be some new words that you need to familiarize yourselves with and understand as we get along. Right. Vocabulary and meaning. Let us touch on the vocabulary and meaning. Not that much here because we talk about similarity and congruency. Now, similar shapes. We say similar shape are the same shape but a different side. Similar shapes, the same shape but a different sides. So it is highlighted in red here, different. But they are what? Same shape. When we say that shapes are similar, it means that these shapes must be the same. But they differ in what? In size. They are the same, but they differ in what? In size. And then congruent, the same size and shape. Careful there, highlighted in blue there, guys. Same what? Size and what? And shape. So you cannot say a certain shape is congruent. But when you check that shape, they are not the same size and they are not the same shape. So they must be the same shape, they must be the same size. But with similar, they must be the same shape, but the different size. They may not be equal in sizes, but we will see to it when we get to them later on. Now let us continue, guys. Now let us take a look at the following examples. Here it is said to you guys, 3 groups of quadrilaterals are shown on this page and the next. So you would see when we go to other pages. What makes each group different from the other groups, apart from the colors? Now we've got group 1, group A, group B, group C. Now here on the screen, guys, it is only group A that are here. Just take a look at these shapes. We want to identify What makes each group different from the other groups? Can we see the shapes there, guys? There are 1, 2, 3, 4, 5, 6, 7. So we have 7 shapes. 1, 2, 3, 4, 5, 6, 7. And we may say something. Our thinking, guys, in this part, guys, is around similar and congruent. So it's between the two. We have to always, when we check, we are looking for similarity and congruency. So we just have to check. Remember, we know what similarity means. It means that they must be the same shape but different size. Different size. But congruent means that they must be the same shape and the same size. Must be no shape that is bigger than the other. They must be the same shape and the same size. If we talk about a rectangle, it must be a rectangle and a rectangle. And they must be same size, same shape. Right. These are the shapes in group A, guys. I believe now we've got time. We have time to look at them. Let us move to the next group of shapes. Then we have group B. Let us look at group B shapes there, guys. 2, 4, 6. We have got 8 shapes there. Something about congruency, something about similarity. I don't know, guys, but we can see there. All right, let us move to group C. Oh, let me just wait a moment, guys. Our thinking again, like I was saying, is around similarity and congruency. So our thinking, when we look at these shapes, will be around similarity and also congruency. So when we look at these shapes, we are thinking between the two. All right, do I see something similar? Do I see something congruent? I don't know, but we can see, guys. Like, check, for example, in group A. Do we see something similar? Do you see something congruent? I don't know. You guys will tell me. Then group C. Here are the shapes in group C. Same size, different shapes. Same shape, same size. Congruent, similar. Right. So let me go back again. Here, the most important part, why I brought you back here is that there was a question. What makes each group different from the other groups? Apart from the colors, we know that the first one's yellow, blue, and red. But now, what makes each to be different from other groups? What makes group A to be not the same as group B, and group B to be not the same as group C, if they are not the same? Or what makes group A to be the same as group B, or what makes group B to be the same as group C? Right. Now, based on our observations, guys, we need to now come to conclusion. These are the shapes. Group A shapes, group B shapes, and group C shapes. Right about now. Now here, let us get to see that. It says here to us, shapes that have the same form, such as the blue shapes on the previous page, are said to be similar. Let me just follow my cursor there, guys. Shapes that have the same form, such as the blue shapes on the previous page. Blue shapes are said to be similar to each other. Let us see if ever there is similarity there, guys. Remember about similarity, it said that they must be the same shape but different sizes. Yes, you can see. These are the same shape. I can see one thing and the same, but they are different in sizes because this one is bigger than this one. And also this one is bigger than this one. Also this one is bigger than this one. So it means, yes, they are similar, that this is true. Similar shape may differ in size, but will always have the same shape. Even though they may differ, look at this example here. They may differ in size. We talk about what? Similar shape. Similar shape may differ in size, but will always have the same shape. Let us look at this one. Do we see there? They are not equal. This one is bigger than this one. Though they are similar, they are not congruent. remember about congruency, guys, is that there must be the same shape and the same size. Here it is an example of a similar shape. This part is there. This part is here. This part is there. So it means this, if you would think about what we covered on enlargement and reduction, this will be a reduction of this, or this will be an enlargement of this one. So we see these two shapes are what are similar. Shapes that have the same form and the same size, such as the red shape, these ones, same size, such as red shape, same form, same size. Same form, same size. When we observe the curves, we can see all these shapes, they are all equal. They are all the same size. They are all the same shape. Is one shape here across. One shape, same size. Now let us see again. What do we call them? Are said to be congruent to each other. These shapes are always the same size and shape. They will always be the same size and shape. Example of congruent shape here. The other one may not be bigger than the other one. Otherwise, it is not a congruent shape. When we say that shapes are similar, they must be the same size and the same shape. May not be a square and a rectangle, square and a triangle, square and a circle. No, it cannot be. It will be the same size, the same shape. Then it means that these shapes are congruent. We can see there when we have touched on the markings there. That shows. Right. Now the question is, are the red shapes on the previous page similar to each other? Similar. These ones, are they similar to each other? The answer would be no, guys. Remember, we said about similar shapes is that they may be the same size but different. They may be the same shape, same shape but different sizes. So in these red shapes, they are all equal. So they are not similar. They can only be similar when they are the same size, the same shape but different sizes. Similarity is all about same shape but different sizes. Sizes may not be the same in similarity. But when it comes to congruent, congruent is very strict, guys. It says same shape, same size. Non-negotiable. Then you can say this one is congruent. But if it is a shape that is the same size but different shapes, or same shape, different sizes, it is not congruent, it is similar. Same shape, different sizes. So guys, it is very important that we get the difference between similarity and congruency. Congruent, same size, same shape. Similarity, same shape, different sizes. Right. So we have already covered there. So we say here when we answer that question that was asked there, it says group A, all of the quadrilaterals have different properties. None of them have the same shape or size, which was this one, group A. None of them have got the same size or shape. So they do not belong to one class of quadrilaterals. Because why we said none of them have the same shape and or size. Let us look at group B. Group B says all of them have the same shape but different sizes. Here we've got the same shapes, but they differ what? In sizes. Here is group B. Now, are these group B shapes similar or congruent? Okay, let me repeat my question again. Are these shapes similar or congruent? We could see that these shapes are the same shapes. But what differs is that they are different in sizes. This is not equal to this, this is not equal to this, this is not equal to this, this is not equal to this. So they differ. all of them have the same shape but different sizes. Now the question would be, are they similar or congruent? Yes, very good. Similar, they are similar because they are same shape but different sizes, meaning that they are similar. Group C, which is these ones, are they similar or congruent? All right, yeah, we can see here. These are congruent shapes. Why? Because they are same shape, same size. Same shape, same size. Same shape, same size. They are all equal. So when they are same shape and same size, then they are said to be congruent. All of the shapes have same shape and size. So are they congruent? Yes. Right. Let us get to exercise 1 now. We are done with the examples. Now, look at groups D, E, F, and G on this page and the next. In each case, say whether the shapes are similar and congruent, similar but not congruent, or neither similar nor congruent. So we are giving guys 3 options there. Whether the shapes are similar and congruent, or similar but not congruent, or neither similar, neither congruent. Now we need to find out. So we are tasked to look at the groups D, E, F, G. Now let us start with a group D. Remember the options are similar and congruent, neither similar nor congruent. Right. Let us look at the first group, group D. Here is the group D. Let us observe the shapes in group D together, guys. Let us observe these shapes. Now we need to make a decision there, guys. I'll give you some 2 minutes to go through it and make that decision. That are they similar and congruent? Similar but not congruent, or neither similar nor congruent? They are not similar, they are not congruent. So let us see group D. I'll give you guys 2 minutes to go through it and draft down your answers. So in your answer, you'll choose between those 3 that were given to us. Let me just highlight them again here. Here's your first answer. You can, if you look at the shapes in group D, you will say they are similar and congruent if you find them to be similar and congruent, or they are similar but not congruent if you found them to be similar but not congruent, or neither similar nor congruent, which means they are not similar, they are not also congruent. So here is our first group of shapes. 2 minutes, your 2 minutes has already started. All right, guys, your 2 minutes has lapsed. Now let us come to a decision. Right, here are the corrections. Let us see. My finding is that shapes in group D, let me just put it, guys. Shapes in group D are similar, yes, but not congruent. Remember, we said a shape to be congruent, it must be same size, same shape. Same shape, same size. Same shape, same size. So in this case, these shapes are similar, but they are not congruent because they are not same shape, same size. So we are together there, I hope, guys. Let us move now to group E. Again, guys, I'm giving you 2 minutes to go through it. All right, guys, your 2 minutes has lapsed. Now let us get to see the findings. All right. Now, what do we say about shapes in group E? Shapes, yes. Shapes in group E. In group E are similar. That's what I found. Yes, are similar and congruent. Guys, we have observed those shapes. Shapes in group E are what? Are similar. Are similar and congruent, meaning that they are same shapes and same sizes. They are same shapes and same sizes. Whereas in group D, similar shapes, they are same shapes but not same size. So that is very important there, guys. So the shapes in group E are similar and congruent. That means they are same shape and same size. Let us look at them again. Yes, they are same shape and same size. These shapes are equal. You see, all of them are equal to each other. If they are like this, then we say these shapes are similar and congruent. Whereas in group D, the shapes were similar, but they were not congruent. For example, this shape is similar to this shape. This shape is similar to this shape. This shape is similar to this shape. But are they congruent? No, they're not equal. Whereas when you look here, they are same shape and same sizes. Good. Again, guys, let me give you another time. Let us look at group shapes in group F, and be careful there. Shapes in group F. 2 minutes. Right, guys, our 2 minutes has lapsed. Now let us get to answer them. What do we observe there? We observe that shapes in group F are similar. I could see similarity there, guys, but different. I'm sorry, not different, but not congruent. Are they the same shape? Yes. Are they the same shape in group F? Yes, they are the same shape. But are they same size? Definitely no, they are not same size. This one is smallest, is the smallest one. This one is the biggest. This one is the second biggest. This is big than this one. Can you see? So they are the same shape but different sizes. So it means that they are similar but not congruent. Right. Let me just put my answers there. Group D, they are neither similar nor congruent. Why? Because the shapes were looking a bit similar, but they were not congruent. Group E, they were similar and congruent. Yes, we have agreed. Group F, they were similar, but not congruent. They were similar, but not congruent. And I could not find group G there, guys. Came as a mistake. Group G. So we could not place group G there. Right. Now, let us look at the following example. Let us look at the following example. We will fix that group G then. Now, in this example, guys, let us observe. It says, are these two shapes similar? These two shapes, we've got this shape and this shape. Are they similar? I would say yes. They are similar. Are they congruent? Definitely no. We can see this is bigger than this one, so they are not congruent, but they are similar because this looks exactly like this. It has got 1, 2, 3, 4 sides. 1, 2, 3, 4 sides. So they are similar. Now answer. Side AB, small letters AB and side capital A, capital B form one pair of corresponding sides. Side AB, which is this side AB, which is this side AB, is 15 centimeter long. Yes, we can see. And side AB is 10 centimeter long. Side AB, which is this one, capital A, capital B. The ratio of small ab to the ratio of capital AB is, which is 15 is to 10, which is 3 is to 2 in simplest form. After it has been simplified, it is 3 is to 2. If the two shapes are similar, the ratios of all the 3 remaining pairs of corresponding sides will also be equal to 3 is to 2. Now, what are they saying there to us? They're saying, as much as we have seen that these shapes look similar, because we have seen they look very similar, but they say if the two shapes are similar, the ratio of all 3 remaining pairs of the corresponding sides will also equal 3 is to 2. Remember, they only tested the ratio of side AB, which is the small a, small b, to the side capital A, capital B. And they found the ratio to be 3 is to 2 in a simplified form, meaning that they found the number that can go into 15 and also into 10 without leaving any remainder. Right, which was in this case 5. 5 could go into 10 3 times, 5 could go into 15 3 times, and 5 could go into 10 2 times. So the ratio in the simplest form is 3:2. Now they say if the two shapes are similar, the ratio of all three remaining pairs of the corresponding side will also be 3:2. Let us see. Side BC, which is a small bc, correspond to side B, capital C. The ratio of their length is 18:12 or 3:2. How do they get to 3:2? Again, they simplified the ratio. How do they simplify the ratio? By finding a number that can go into 18 and also go into 12. The same number that can go into 18, it can also go into 12 without leaving any remainder. Let me repeat. A number that can go into 18, but the same number, if it goes to 18 without leaving any remainder, it must also be able to go into 12 without leaving any remainder. So that number that they could find there was 6. 6 goes into 18 3 times. 6 could go into 12 2 times. So the ratio is 3:2. 3:2, which was the same as the first pair. Let us see. Side CD, which is CD, corresponds to side CD, capital C, capital D. The ratio of their length is 12:8. Again, similar. Why? Because when you simplify 12:8, there is a number that can go into 8 and into 12 and into 8 without leaving any remainder. And that number is how much? 4. 4 goes into 12 3 times. 4 goes into 8 2 times. So it boils down to a ratio of 3:2 again. Let us continue. Then side DA corresponds to side capital D, capital A. The ratio of their length is 9:6. Remember, 9. It is this one, DA, 9, is to 6, which is this capital D, capital A, this one. Therefore, their ratio is 3:2. Now, all pairs of corresponding sides are in the same ratio. The two shapes are similar. Right, guys, what we are learning out of this example is that we cannot just quickly confirm something is similar or congruent. The first thing that we need to be very careful of when we decide something, some shapes to be similar or shapes to be congruent or shapes to be not similar, is for us to find the ratio. Check the ratio between the corresponding sides. The corresponding sides, which is, here is going to be BC and BC. AB, AB. AD, AD. DC, DC, or CD. Just like that. So after having found the ratio in a simplified manner, if it can be simplified, and being the same ratio across, then yes, those two shapes, they are said to be what? To be similar. Moving on. Another example here, guys. The rectangle on the right are similar. Alright, here we are already told. The rectangles on the right are similar. Calculate the length of side GF. Now let us see how they did it. They are showing us here. Side EF correspond with this side EF, small EF correspond with the side capital EF. And then their ratio is 5:8 because we are moving from this one to this one. So we start with this one where we started from. And then side GF correspond with side capital G, capital F. There too, and GF. The other one is provided 11 meters and the other one is not provided. It's a question mark of meters. And then the two shapes are similar. So the ratio of GF and capital GF must equal the ratio of capital E and capital F. I'm sorry, small EF and capital EF. Now, when we solve it, because we were told initially that these shapes are similar, so we know that their ratio, it means that their ratio was across all the sides, the ratio was the same. So now we start to solve it. Now solving this, it means that we let the length of a side, which is GF, be y, or a variable y. So we'll say the ratio was, because they were similar, it will mean that 11, which is the one that is given, is to the one that is unknown, which is also equal to the ratio of the known two side 5:8. Then from there on, guys, it's a matter of simplifying. And when we simplify, we go on and on and on, and then the explanation is there that we cannot divide two fractions, because remember here, the first objective was to get rid of this y. So to get rid of this y, you must what? Because it is divided by y, you will multiply by y over 1. So this y will cancel that y. And then you'll, whatever that you do on the left-hand side must also be done on the right-hand side. Here we'll also multiply by y over 1 or that matter. Therefore, after having done that, we want to get rid of this. We want to solve y. Therefore, we will divide, because it was multiply, we will divide by 5/8. But because it's a fraction, and this 11 is the same as 11 over 1 as a fraction, so we cannot divide two fractions. We do what? We multiply by an inverse, which is going to be 11 multiplied by 8. Inverse of 5/8. 8 comes on top, 5 comes down, because it's an inverse of that. Then we'll multiply by 8 is 8, and then divide by 5. Then you'll get 17.6 meters. So the length side of GF is 17.6 meters, which we were asked to do. Right. Now let us try it practically together, guys. Now let us look at the following. It says in A to C below, the shapes in each pair are similar. Calculate the length of each indicated side correct to 2 decimal places. Calculate the length of each side indicated, or each indicated side correct to 2 decimal places. Be careful. You are already told that they are similar. So I'm going to give you guys 5 or 6 minutes. Let us work on 6 minutes and solving, say A, for example, only A for the time being. Then we'll come to the rest. Let us 6 minutes, guys. Let us solve A first. These first two. So your 6 minutes begins now. Oh, guys, I'm sorry, I did not emphasize that we are looking for the sides that are unknown. Here is this x. Here is this x here, which is line DC. So the other line, capital DC, is provided. So you're looking for this line DC here. Thank you. So your 6 minutes has already begun, guys. So let us work with what we are having. Right, guys. Welcome back. Right, guys. So we are busy with the similar shapes. Now, when we check here, we were told to find the missing part there, which is line DC. Now, in line DC here, guys, we need first to identify the ratio. We need to find the ratio of any other side, any given side that can help us so that we can be able to apply that ratio. Should we find the ratio, then it's a matter of simplifying. So let us see. I've just completed drawing this shape. Right. So guys, here is the shape. We are only doing part A. Now, let us observe this shape. Like I said, we need to find the corresponding sides. Now here, let me say A, this B is going to be a small b, and this will be my small a, so that everything we can make it simpler for us, and it could be easier. First thing that we need to do, guys, is to find all corresponding sides. So here, in here we have a corresponding side AB here. It is corresponding to this side. Nah. And also, we have got side BC. Let me just write, is corresponding to this my new created small side BC. So it is very important to find the corresponding sides. But here is the thing. We have got the side DC here. And then we have got the corresponding side DC there. And then we have got the corresponding side A. We've got the side AD. We've got the side AD. And we've got the corresponding side AD. So we have found all the corresponding sides. But after having identified all the corresponding sides, it does not say that all the corresponding sides are going to help us. We would have to find the corresponding two sides that have got measurements so that we can find the ratio of them. We've got to find the two sides that do not have anything missing so that we can determine the ratio. After having found the ratio, it is a matter of us substituting. So I'm going to help you guys to identify the ratio. So let us see. Let us find the two sides that are corresponding and have values both. So with me here, I've got the side DC, capital D, capital C, and I've got the side DC, which I'm looking for. This is what I'm going to calculate. This is what I must calculate here. But here's the problem. I have side BC and I have corresponding side BC. These two sides definitely are the ones that are going to help me. So what do? I need to find the corresponding sides that have got measurements first, and I need to identify the ratio of the corresponding sides in a simplified form. So what I'm going to do, I'm going to start with the ones that I'm given. Capital A, capital side A, B, sorry there guys, capital side B, C, is 2, because those are the two sides corresponding. Side B, C correspond to side B, C. So it will be, it is 2, B, small c. So the side capital BC equals to 30 centimeters. So I will put it 30 centimeters is to side small b, small c, 24 centimeters. 24 centimeters. Now, after having done that, guys, I need to put these two corresponding sides I need to simplify them. I need to write them in a very simplified manner because I could see that these numbers are both even, so I can be able to simplify them. So in a simplified manner, I would find a number that can go into 30 centimeters and also that can go into 24 centimeters without leaving any remainder. So the number there that can go into 30 and 24 is 6, the biggest number. We're looking for the biggest number, because the smallest number will keep us solving. So the biggest number will just get us to the solution. So 30 divided by 6, we'll divide by 6 both sides. So 30 by 6 is equals to 5 centimeters. Is 2. 24 divided by 6 is 4 centimeters. Therefore, our ratio is going to be 5:4. This is our ratio. Now guys, when you have found the ratio, everything will be much simpler because you are looking for side DC, which has got a corresponding side DC. So you will take the corresponding side DC, capital D, capital C, corresponds with the side small d, small c. They are equal to the ratio of 5:4. Therefore, when we continue, we would find the length of DC, which is the capital DC. In this case, it was given to us as 23 centimeters. The side DC, it is given to us as 23 centimeters. So we'll replace that. DC will be 23 centimeters, all divided by the side DC, small cd or DC, this side. It is given to us as x. In other words, we need to find it. So we will put what? X here. Is equals to 5:4. We use now the ratio because we needed to identify the ratio first so that we can use it to find the length of the missing side. From here on, guys, it's a matter of substitution and solving. So it's going to be very simple for us. After we're here, then just a matter of simplifying and solving, guys. So the most important part that I wanted you guys to know is to find the ratio and find the ratio in a simplified manner, and then know how the ratio is applied in finding the solution of the question. Right? So, guys, due to our timing constraints, guys, please complete this. Do B as well, and then do number C as well. Because remember, this X is not visible enough, but here, line QR has got an X there that you must find, which is corresponding to capital R, capital Q here, which is 68 centimeters. Here you are finding line JM, the value of X there. There is an X here, which is corresponding to the line JM here, which does not have anything to offer. But again, you need to find a ratio of all the given sides. Here we've got a ratio, we've got JK, which is corresponding with this JK. We've got PS, which correspond with PS. So we will be able to find the missing unknowns. Right? Thank you, guys. You guys have been wonderful. I hope to see you more and more again. And I hope, guys, in what we have learned with regards to similarity and congruency, we will grasp it, we will run with it, we will never fear them. Remember, guys, when we started, we spoke about vocabulary that we need to familiarize ourselves with. Please visit that vocabulary most often. Number 2, we emphasized the similarity and the congruency. We said shapes that are similar, they are of same shape but different sizes. Remember that similar shapes are of the same shape but different sizes. But shapes that are congruent, those are the same shapes, same size. They must be equal in size, they must be equal in shape, so that we can say these shapes are congruent. And we have also touched on the part where we are calculating the ratio, and we are also finding the unknown side of the shape. So I hope you guys will practice all the activities that are posted here while we're doing our presentation. And guys, please visit this video, visit this video, do more activities, practice, practice, practice. You guys have been wonderful. I hope to see you again. Thank you, thank you, thank you.